Welcome to the first part of the essentials of the course Energy Supply for Buildings. In this first part you will learn about the energy chain and make an inventory of the diverse energy conversion systems for buildings. Let's start first with the energy chain. The energy chain consists of four main components, pictured here from left to right. The first one is the supply side, consisting of all natural resources needed to produce energy, the so-called primary resources. They are divided into four categories. First, in dark red, the fossil fuels that can be burned like coal or gas and the non-combustible ones like uranium used in a nuclear plant. Above, in dark green, you see the combustible renewables like wood, biomass or biogas. These are not infinite sources and their use must be very well fitted to their rate of production, otherwise natural resources may be depleted here too. The energy content of these resources is called primary energy. Finally, below, in light green, we have the non-combustible renewables like solar and wind energy. These are infinite resources. There is therefore no depletion. The second component of the chain is the energy conversion process, by which natural resources are converted into useful energy in the form of electricity, heat or cold. During the conversion of natural resources into energy, many environmental impacts like CO2 emissions take place. This series of lectures is about these two first parts. The third part of the energy chain consists of the energy storage and distribution of this energy to and inside buildings. This will be addressed further in the course Efficient HVAC Systems. Finally, we have the last part of the chain, which is the energy demand in a building. The energy demand tells us how much energy should be brought to the building and is the subject of another lecture in which you learn out how to make estimates of this energy demand. The energy chain is extremely useful and we will use it a lot to design efficient and sustainable energy and indoor climate systems for buildings. You will learn in this course how to estimate the primary energy needed to meet a certain demand for heat, cold and electricity by using the efficiency of the conversion system and the energy content of the resource used. That will also help you with calculating the CO2 emissions. However, this energy perspective does not completely fit with the daily experience of energy and energy bills. The energy bill relates to the energy delivered to the buildings. It is what we call the final energy. Final energy may be primary energy, a natural resource, therefore, like gas or wood pellets. In that case, the natural resource is delivered to the building and energy conversion takes place inside the building. But the conversion of resources to usable energy may also have taken place outside the building, like electricity produced in a power plant by burning gas. The energy conversion inside buildings and the distribution of it in rooms is generally referred as HVAC systems, heating, ventilation and air conditioning. What is called final energy is therefore a mix of primary resources and already converted useful energy. It is what you pay for in your energy bill. In this course, we will consider mainly primary energy and address final energy only when it comes to energy costs. Let's start with conversion systems for heat for space heating as well as for hot tap water. It is possible to use direct electrical heating, for instance for the shower, but also electrical boilers or electrical convectors. Second, we can burn fuels, wood in a fireplace or wood pellets or other types of biomass and biogas in a boiler, or coal in a stove, gas in a gas boiler or oil in an oil boiler. Third, we can use heat pumps. ground source or air heat pumps, and fourth, geothermal energy. By the way, heat pumps may use a combination of electricity and geothermal heat. Fifth, we can also use waste heat, or in other words, reuse waste heat from diverse industrial processes and power plants. This heat would be otherwise lost to the environment. And finally, we have solar heat for hot tap water and sometimes also for space heating. Let's look now at conversion systems for cold. I guess you are aware of air conditioners or chillers and cooling machines, right? But do you know that all three are identical and work according to the exact same principle as the heat pump? A chiller is a heat pump working in cooling mode, just like a fridge. Or a heat pump is a chiller working in heating mode, whatever you prefer. Are you also familiar with these small air coolers that are sometimes sold as being air conditioners but are not, the ones like in the picture? These ones are not heat pumps and work according to the principle of evaporative cooling. They are sometimes also used in streets when it's really warm and are then called mist coolers. Maybe you also thought about fans? Fans are a very good way to cool the human body by increasing the convection losses around it and the uptake of sweat. However, they do not cool the air, so we don't count them as a process to produce cold. There is still one possibility left, and that is the use of environmental cold. Very often the ground or rivers and lakes or the sea are colder than the indoor air. They can then be used to cool buildings. Even night cold air can be used. So, in the end, we have only three ways of producing cold. Let's now have a look at the production of electricity, also called power. A power plant does not refer to a specific technology, but to any large electricity production site. However, power can also be generated locally. Starting with what is commonly called a generator, these are more or less portable systems that generate electricity on remote sites based on burning fuels like diesel or oil. We call them combustion engines. As for the large power plants, most of them are turbine-driven. Turbine technology is used to generate electricity in a generator. The turbine may be powered by high-pressure steam or gas obtained by burning fossil fuels like oil, coal, gas, but also municipal waste, biomass or biogas. Instead of burning fuel, nuclear energy can be used as well. Steam can also be obtained from geothermal energy. A byproduct of many of these power plants is heat, which can be used to heat buildings. Turbine technology can also use other drivers than steam or gas. It can be powered by wind energy, by hydropower, tides, or even ocean waves. It is also possible to produce electricity by chemical reactions, and that is what a fuel cell does. By having hydrogen reacting with oxygen from air, electricity can be produced together with waste heat. And of course, we have photovoltaic cells, sometimes called solar panels. But don't confuse them with the panels for solar heat we discussed at the start of the presentation. The working principle is completely different. Last but not least, there are many emerging technologies like solar-powered Stirling motors, thermoelectrical energy exploiting vertical temperature differences in oceans, or electricity produced from vibrations that will not be handled here. So we end here with 6 groups of technologies to produce electricity. To summarize, we have categorized heat, cold and electricity conversion systems into only a few categories. Happily enough, there are not hundreds of ways to produce them. We have seen that heat can be obtained from electricity, fuel burning, heat pumps, geothermal waste heat and solar heat. As for cold, it can be produced by cooling machines that are exactly the same as heat pumps, by evaporative cooling, and by using environmental cold. Concerning electricity, we saw that it can be produced with generators based on combustion engines or turbines. Generally, waste heat is produced as well. Wind and hydropower are also turbine-based technology, while fuel cells are based on chemical reactions and produce waste heat and electricity. And finally, we have photovoltaic cells producing electricity from the sun. This brings us to the end of this lecture. The second lecture will handle primary energy and CO2 emissions. In the third and fourth parts, you will learn more about the working principles and CO2 emissions of the different systems. Thank you for your attention. Goodbye.